There is a rice paddy in rural Japan that has been producing food every single year for over 1,000 years. Same soil, same field, no synthetic fertilizers, no chemical inputs of any kind. And right now, in 2026, that field is more productive than the industrial farm surrounding it. I want to tell you about that because it means something. Most of us who grow food, whether it's a backyard garden or a serious homestead operation, have been handed a model of farming that is about 70 years old. Synthetic nitrogen. Phosphorus in a bag. Spray what moves, kill what competes. And it works, for a while. But there's a reason experienced growers keep noticing the same thing. That after years of feeding plants with bottles and bags, the soil somehow feels emptier. The yields drop. The pests get worse. You buy more inputs, and it never quite resolves. Japanese rice farmers figured out something different. Not recently, 3,000 years ago. And what they built, the actual system, the specific techniques they used, is now being validated by modern soil science in ways that should make every person who grows food sit up and pay attention. By the end of this video, I want to show you what that system looks like, why it works, and one specific technique from traditional Japanese farming that produces more food from the same soil every single year without adding anything from a store. And the last thing I'm going to share, an ancient method that disappeared for 60 years and was brought back by one farmer in rural Fukuoka, should completely change how you think about what a garden actually is. Let's start with what happened in the middle of the 20th century, because it explains everything. After World War II, American agricultural advisors arrived in Japan and brought modern chemical farming with them. Synthetic nitrogen fertilizer, pesticides, mechanical tilling, and the results were genuinely impressive in the short term. Japanese farmers could produce roughly the same rice yields as before, and they could do it in half the time. That felt like a miracle. So within one generation, almost every rice farmer in Japan made the switch. But here is what nobody mentioned at the time. For centuries, for 3,000 years, Japanese farmers had been building something in that soil. Organic matter, microbial life, a slow accumulation of biological complexity so deep and intricate that scientists are still mapping it today. And when synthetic fertilizers replaced the organic system, that entire structure began to collapse. The humus built up over 3 millennia was depleted within a single growing generation. Farmers didn't see it coming because the yields stayed the same. The synthetic inputs were just directly feeding the plants, bypassing the soil entirely. The soil itself was becoming hollow, a growing medium instead of a living system. This is the story modern agriculture doesn't want to tell you because the solution to it is not something you can buy. The traditional Japanese approach to farming is called satoyama. It's a compound word. Sato means village, yama means mountain, and it refers to the entire landscape surrounding a farming community, managed as a single integrated system. Not just the rice paddies, not just the vegetable fields, the forests, the irrigation ponds, the grasslands, the woodlands where leaf litter was gathered, all of it working together, feeding the paddies with nutrients in a continuous loop that researchers today call a circular bioeconomy. Though the farmers who designed it never would have used that phrase. Here's how it actually functioned and why it was so resilient. Before synthetic fertilizer existed, every village in Japan needed an enormous supply of organic material to feed their rice paddies. We're talking about serious quantities. Researchers who have studied these historical systems calculated that a village farming 100 acres of rice needed over 1,000 acres of surrounding woodland just to produce enough leaf litter for compost. That is a 10-to-1 ratio of managed forest to farmland. Think about what that means. The farming was not just what happened in the paddies. The farming was the entire landscape. Farmers would go into those managed woodlands, collect the fallen leaves, bring them back, compost them with animal manure and human waste, and work the result into the paddies before planting. The trees were coppiced on a 15 to 20-year rotation so they'd produce more leaf material. The irrigation ponds caught rain and snowmelt from the forested hills and channeled it through the paddies in a sequence that distributed nutrients as it went. Nothing was wasted. Nothing left the system. What came from the land went back to the land season after season for centuries, and the soil kept getting better. Now, in the 20th century, two people looked at what was being lost and decided to do something about it, and the way they went about it, from completely different directions, ended up proving the same thing. The first was a man named Masanobu Fukuoka, born in 1913 on the island of Shikoku in southern Japan. Fukuoka was a scientist. He studied plant pathology, worked as a customs inspector in Yokohama, not a back-to-the-land idealist. But at the age of 25, recovering from a severe illness in a hospital in the city, he had what he later described as an experience of sudden clarity. He looked out at the world and saw that everything modern agriculture was doing, the plowing, the fertilizing, the pest management, the constant intervention, was solving problems that traditional farming had never created in the first place. He went home to his family's farm in Shikoku and started dismantling his approach piece by piece. First, he stopped plowing. Conventional wisdom said this would ruin the fields, the compaction, the weeds, the reduced aeration. He watched what happened instead. The soil, left undisturbed, began building structure on its own. Earthworms returned. Fungi spread. The root systems of cover crops he planted broke through the subsoil layers that plowing had never reached. After a few seasons, the unplowed soil was draining better and holding more moisture than the tilled soil in neighboring fields. Then he stopped using fertilizer. He let the straw from each harvest fall back into the field rather than removing it. He interplanted clover and deep-rooted plants, daikon, burdock, dandelion, whose roots broke open the soil and whose decomposing leaves fed it. And he watched the soil fertility not decline, but increase. Every season, measurably more complex, more alive, more capable of feeding a rice plant without any outside input. Over the next 3 decades, Fukuoka refined this into what he called his do-nothing method, which is a misleading name, because it wasn't nothing. It was a precise understanding of what nature already does when you stop interfering with it. By the 1970s, his fields were producing rice yields comparable to the highest performing conventional farms in Japan, using no fertilizer, no pesticides, no tilling, and a fraction of the labor. His book, published in 1975 under the title The One Straw Revolution, was translated into more than 25 languages and has sold over 1 million copies. Michael Pollan called it one of the most important books about food and agriculture ever written. But Fukuoka's method is also demanding in a way that most farmers couldn't replicate. It requires years of transition. It requires deep familiarity with your specific piece of land, and the results, while real, take time to fully materialize. Then, in the 1980s, about 40 miles from Fukuoka's farm, a rice farmer named Takao Furuno discovered something that produced dramatic results far faster, and it came from the most unexpected direction. Furuno had already been farming organically for a decade, motivated, he later said, by reading Rachel Carson's Silent Spring, the book that first exposed the ecological destruction of chemical pesticides. He was producing organic rice, but weeding was destroying him. Manual weeding of rice paddies requires an estimated 240 person-hours per hectare every single year. That is almost incomprehensible labor. Herbicides solve the problem, but they also poison the paddy ecosystem, the water, the soil biology. Furuno didn't want to use them, but he was running out of options. Then he heard about an old method that some farmers in his region had used generations ago, before the chemical era made it irrelevant. You released ducks into the paddies. The concept sounds too simple to be real. But here's what actually happens when you put ducks in a rice paddy and why it works so much better than anything else. Ducks eat weeds. Not occasionally, they eat them continuously, systematically, waddling through every row, consuming the aquatic plants that compete with rice before they can establish. They eat insects. They eat snails. The golden apple snail, an invasive pest that can devastate young rice seedlings, is no match for a duck. They eat it enthusiastically. As they move through the water, their feet stir the sediment, introducing oxygen into the soil in a way that stimulates the beneficial microorganisms in the paddy. And every moment they're in the water, they are depositing organic material rich in nitrogen, phosphorus, and potassium directly into the field. The ducks are simultaneously a pest control system, a weeding crew, a soil aeration tool, and a fertilizer delivery mechanism. And they do it for free, in exchange for a fence and some supplementary grain at night. Furuno's first experiment worked, but not without problems. The ducks were too old when he released them and started damaging the rice plants. Dogs ate several of them before he installed an electric fence. Birds of prey took others. He spent years refining the method, figuring out the exact age at which ducklings should be introduced into the paddies, which turned out to be around 7 days old. The optimal number per unit of field is 15 to 30 per tenth of a hectare. The precise timing for removing them before they grew large enough to eat the ripening rice grain. Once he got it right, the results were striking. Rice yields increased. Weeding labor dropped from 240 hours per hectare to near zero. Input costs fell dramatically, and when Furuno sold his organic aigamo rice at premium prices, plus the ducks themselves at the end of the season as table birds, his income from the same 3.2 hectare farm approached $160,000 a year. More than double what a conventional rice farmer would earn. He shared the method through lectures and books and agricultural exchanges with governments across Asia. Within a few decades, an estimated 75,000 farmers across Japan, Korea, China, Vietnam, the Philippines, Bangladesh, Cambodia, and as far as Cuba were using some version of the aigamo duck rice method. A farmer in Laos tripled his income in the first year. Researchers in Bangladesh documented yield increases between 20% and 50% in the first season of adoption. But there's a detail about what happens to the soil in an aigamo paddy that I think is the most important part of the story, and it's the part that almost nobody talks about. Scientists studying Furuno's fields ran nitrogen balance sheets, tracking exactly how much nitrogen was going into the paddy through the ducks and through the ducks' manure, and how much was leaving the field through the harvested grain. The math showed a deficit. More nitrogen was leaving than the ducks were putting in. According to every model, the soil should have been slowly depleted, but when they measured the actual soil nitrogen content at the end of the growing season, it had increased, not decreased. Increased despite a mathematical deficit. The explanation, when researchers found it, was remarkable. The mechanical disturbance of the ducks' constant movement through the water was stimulating populations of nitrogen-fixing microorganisms in the paddy soil, organisms that pull nitrogen directly from the atmosphere and convert it into plant-available form. The ducks weren't just fertilizing the paddies, they were activating the biological machinery that allows the paddies to fertilize themselves. This is what the satoyama system had always known. The fertility was never in the bag. It was in the system. In the relationships between the organisms in the soil and the organisms in the water and the organisms in the surrounding woodland, all cycling nutrients in a loop that maintained itself as long as you didn't break it. Fukuoka knew it. He just proved it by removing all the inputs and watching what the land did on its own. Furuno knew it. He proved it by putting a flock of small ducks to work in a paddy and discovering that they activated something the chemical fertilizer had been suppressing. And the satoyama farmers who came before both of them knew it for 3,000 years before anyone wrote it down in a scientific paper. Here is what this means for anyone who grows food at any scale. The instinct most of us have been given is to solve problems from the outside. Soil needs nutrients, add fertilizer. Plants get pests, add pesticide. Weeds appear, add herbicide. And then more fertilizer to replace what the pesticide killed in the soil biome, and more pesticide because the predator insects that would have handled the pests are gone. The spending never stops because the system never heals. The Japanese approach is the opposite direction. Build the conditions for the biological relationships that create fertility. Reduce inputs. Welcome the organisms, the ducks, the insects, the fungi, the nitrogen-fixing bacteria that do the work you've been paying for, and then get out of the way. The rice paddy that has been producing food for over 1,000 years in rural Japan has never received a single bag of synthetic fertilizer. It doesn't need one. The system itself is the fertilizer. Every organism that lives in and around that paddy is doing a job that the soil chemistry textbooks are still trying to fully describe. We built something simpler, shorter, and far more expensive to replace it. And we called that progress. The farmers working the old way looked at what we built and kept doing what they'd always done. Their soil keeps getting richer. Their yields stay stable. Their input costs remain close to zero. Masanobu Fukuoka farmed that way until he was well into his 80s. He lived to 95. Takao Furuno is still farming in Fukuoka Prefecture today. And somewhere in rural Shiga Prefecture, a natural agriculture farm is producing rice from soil that has never been touched by a synthetic chemical, where 5 plant species considered ecologically extinct in the region have quietly reappeared in the paddy margins, drawn back by the return of a system that was always waiting to rebuild itself. That field isn't a relic, it's an answer. If this changed how you think about what fertility actually is and where it comes from, I'd love to hear about it in the comments. There's a lot more of this kind of deep dive into traditional agricultural knowledge from cultures that have been doing this far longer than the chemical era has existed. Hit subscribe if you want to see more. I'll see you in the next one.